Look up on a clear night, and you are not looking at empty space. You are looking at the largest unclaimed vault humanity has ever laid eyes on, packed with gold, platinum, water, and enough raw energy to outlast civilization itself. One metal world drifting between Mars and Jupiter has been valued on paper at $10,000 quadrillion. That is something like 70,000 times the size of the entire global economy. It is also just one target among dozens scattered from our own backyard to the edge of the observable universe. Here is the part almost nobody puts in the headline. If you could actually drag that fortune home, the number on the page would not make you rich. It might do the opposite.
So what is all of this actually worth? Why cannot we simply cash it in? And what does the answer teach us about wealth itself? Not just out there, but right here on Earth. To find out, we are going to take a tour. We will start close, at our own moon, and work outward, past the asteroid belt, past the gas giants, past the edge of our solar system entirely, until the numbers stop making sense in a way that says something true about money itself.
Begin 238,000 miles from home. The moon has no atmosphere and no magnetic field, which for 4.5 billion years has meant one thing. It has been standing directly in the path of the solar wind, with nothing to block it. Charged particles have rained down onto the lunar surface for longer than life has existed on Earth, and some of what they left behind is a rare isotope called helium-3. Researchers estimate roughly 1 million tons of it sit locked inside the moon's dust, in concentrations measured in parts per billion. On Earth, helium-3 is almost non-existent.
In a working nuclear fusion reactor, it is close to a dream fuel, producing enormous energy with far less radioactive waste than conventional reactors. There is a real reason space agencies and private companies are already scouting the lunar surface with this isotope in mind. But here is the catch nobody mentions in the excited headlines. Commercial fusion power does not exist yet, anywhere, at any scale. Multiple feasibility studies on lunar helium-3 mining have reached the same uncomfortable conclusion, that under current technology and current fusion timelines, the economics only barely work, and only in the most optimistic, large-scale scenarios.
The moon might be sitting on a fortune. Whether anyone can actually spend it depends on a fusion breakthrough that has not happened yet. Move a little farther out, into the population of rocky bodies that occasionally swing close to Earth's orbit. In September of 2023, a NASA spacecraft called OSIRIS-REx parachuted a capsule into the Utah desert, carrying about 4 ounces of black dust and pebbles scraped off the surface of an asteroid named Bennu. When scientists finally opened it, they found something worth more than any metal. The sample contained amino acids, the building blocks of proteins, along with all 5 of the molecular bases used to build DNA and RNA.
It also held ancient salt crystals left behind when salt water evaporated on Bennu's long-lost parent body billions of years ago. A Japanese mission called Hayabusa 2 had already done something similar 3 years earlier, returning a few grams of material from a different asteroid, Ryugu, that also turned out to be loaded with amino acids. Neither of these asteroids is going to make anyone rich in gold or platinum. What they delivered instead was evidence for one of the oldest questions in science, that the raw ingredients for life on Earth may have arrived here from space, carried inside rocks exactly like these. That is not a number you can put on a balance sheet, and it may be worth more than one anyway.
Now push deeper into the main asteroid belt between Mars and Jupiter, to the target with the number that started this whole conversation. 16 Psyche is a metal world roughly 170 miles across
And unlike almost every other asteroid in the belt, it appears to be made almost entirely of iron and nickel, the same materials found at the core of our own planet. The leading theory is that Psyche is not really an asteroid at all, but the exposed heart of a much larger world, a protoplanet that lost its rocky outer layers in a series of violent collisions billions of years ago.
In 2017, the mission's lead scientist, Lindy Elkins-Tanton, ran a back-of-the-envelope calculation, pricing Psyche's metal at what it would cost to buy that much iron and nickel on Earth's commodity markets. The number that came out was $10,000 quadrillion, the figure that has been driving headlines ever since. NASA launched a real spacecraft to study Psyche in October of 2023. It swung past Mars for a gravity assist earlier this year and is now on course to arrive at the asteroid in August of 2029. Not to mine it, but to photograph and measure it, since it may be our only chance to examine a planetary core up close without drilling through thousands of miles of rock.
Elkins-Tanton has been candid about the limits of her own number ever since. No spacecraft or rocket in existence, or on any drawing board, could physically haul an asteroid the size of a small moon back to Earth. And even in a fantasy scenario where one did, dumping that much iron and nickel onto global commodity markets would crash metal prices to near nothing long before anyone got rich, since the entire $10,000 quadrillion figure only makes sense as long as Psyche's metal stays exactly where it is, completely out of reach.
Mars itself is rich in iron, too, which is part of why the planet is red. Its dust is essentially rusted. Its two small moons, Phobos and Deimos, are still a genuine scientific mystery. Researchers are not certain whether they are captured asteroids or debris blasted off Mars by an ancient impact. Nobody has attached a serious dollar figure to either moon, because nobody actually knows what they are made of yet. Everything so far has been, relatively speaking, the easy part of this tour. Worlds close enough that real spacecraft have already touched them, or are on the way. From here, things get stranger, and the price tags stop being numbers anyone could spend even in theory.
Jupiter alone holds more raw hydrogen than every other planet in the solar system combined. Hydrogen that, in a hypothetical future fusion economy, would be worth an almost meaningless amount of money. Nobody is seriously proposing we siphon a gas giant. There is no engineering path, current or foreseeable, that lets any civilization move a fraction of a planet more than 100 times more massive than Earth. What we can do is study its moons up close. NASA's Europa Clipper spacecraft launched in October of 2024 and is now cruising toward Jupiter, with an Earth flyby scheduled for December of this year and orbit insertion expected in April of 2030.
Its target, Europa, is believed to hide a liquid water ocean under miles of ice, kept warm by the crushing tidal pull of Jupiter itself, and possibly holding more liquid water than every ocean on Earth combined. Farther out, Saturn's largest moon, Titan, is the only other place in the solar system known to have stable liquid on its surface. But that liquid is not water. It is methane and ethane pooled into lakes and seas with names like Kraken Mare. Based on radar maps built by NASA's Cassini spacecraft, researchers have estimated that Titan's lakes alone hold many times more liquid hydrocarbon than all of Earth's proven oil and natural gas reserves combined. And Saturn's small moon Enceladus spends its life firing geysers of water vapor out into space from cracks near its south pole. Geysers that Cassini flew directly through, detecting organic molecules and tiny grains of silica that point toward hot, mineral-rich water meeting rock somewhere deep beneath its icy shell. The
the same kind of environment where life may have first appeared on Earth.
Beyond Saturn, the ice giants Uranus and Neptune hold vast reserves of ammonia and methane ices, useful in theory for future fertilizer or fuel, useless in practice with anything resembling current technology. Pluto and its large moon Charon, both visited briefly by NASA's New Horizons spacecraft in 2015, turned out to have nitrogen ice plains and complex organic molecules called tholins coating their surfaces. Chemistry so unexpected that it rewrote what planetary scientists thought was possible that far from the Sun. Beyond them lies the Kuiper belt, a ring of icy, mostly unstudied worlds so distant and so numerous that nobody has even attempted to estimate their combined value. Now, leave the solar system behind entirely. 40 light-years away sits a planet called 55 Cancri e, twice Earth's size and 8 times its mass, orbiting so close to its star that a year there lasts 18 hours. In 2012, a team of Yale astronomers made headlines around the world by proposing that this planet was made largely of diamond, its interior a thick layer of compressed carbon beneath a surface of graphite. A columnist at Forbes ran the numbers and arrived at a valuation of $26.9 nonillion, a 9 followed by 30 zeros, a figure so large it stopped meaning anything at all. But the diamond story did not hold up. Follow-up research found that the planet's host star contains less carbon relative to oxygen than the original study assumed, and years later, astronomers at the universities of Zurich and Cambridge proposed a different picture entirely, that 55 Cancri e may be rich in aluminum oxide instead, the mineral that forms rubies and sapphires here on Earth. In other words, the diamond planet needed to be reclassified as something closer to a sapphire planet. Even the flashiest number in this entire tour turned out to be built on an assumption that later evidence quietly knocked down. Somewhat closer, 120 light-years away, sits a strange world called K2-18b, a planet larger than Earth that may be covered in a global ocean beneath a thick hydrogen atmosphere. In 2023, and again with stronger data in the spring of 2025, astronomers using the James Webb Space Telescope reported faint traces of a gas called dimethyl sulfide, a molecule that, on Earth, is produced almost exclusively by marine life. It briefly looked like the closest thing to a biosignature science had ever found on a planet outside our solar system. Then, in the summer of 2025, a NASA-led team reanalyzed the same data and found no conclusive evidence of that gas after all. As of this recording, the debate is still completely open. Nobody has priced K2-18b because nobody yet knows whether what is floating in its atmosphere is chemistry or biology, and that uncertainty may be worth more to science than any number we could assign it. From here, let the thought experiment run all the way to its breaking point. Push the tour to the Sun itself, and you reach an object containing more than 99% of all the mass in our entire solar system, radiating more energy in 1 second than humanity has generated across its entire history. Push further to a white dwarf, the collapsed corpse of a star like our Sun, so dense that a single spoonful of it would outweigh a car. Push further still to a neutron star, dense enough that its gravity would visibly bend the path of light passing near it. And finally, to a black hole, like the one anchoring the center of our own galaxy, an object so extreme that the normal rules of physics, the rules that let us calculate a price for gold or platinum or diamond in the first place, simply stop applying. None of this is a real proposal. No civilization, at any level of technology we can currently imagine, could move a meaningful fraction of a star, let alone a black hole. The point of pushing the number this far is not to suggest it is possible.
It is to watch the entire concept of a price tag collapse under its own weight, right alongside the objects generating it. And that collapse is the actual lesson hiding inside every one of those viral trillion-dollar asteroid headlines. A price is not a fixed property of an object sitting out there in the dark, waiting to be claimed. A price only exists because something is scarce enough and reachable enough that people will trade for it. The instant you solve the scarcity by hauling home more metal than every market on Earth could absorb, or by proving that helium-3 fusion actually works at scale, the old price disappears and a new, much smaller one takes its place.
16 Psyche is not worth $10,000 quadrillion sitting where it is. And it would not be worth that much if it somehow arrived on Earth either. It would just be worth whatever iron and nickel become worth after the biggest metal glut in human history. The genuinely valuable thing these missions have already returned is not sitting in a vault. It is sitting in laboratories on Earth right now, in the actual amino acids pulled from Bennu and Ryugu, the actual radar maps of Titan's hydrocarbon seas, the actual open questions still hanging over K218b. That is a kind of wealth that does not lose its value the moment you bring it home. If any of this got your gears turning, that is genuinely the entire point of this channel. So stick around and tell us in the comments which of these worlds you would send humans to first.
Because the honest answer to how much the universe is worth is not a number at all. It is a question about what we are willing to go and learn, long before we ever figure out what, if anything, to bring back. Somewhere past Mars right now, a spacecraft the size of a small car is quietly closing the distance to a mountain of exposed planetary core. Not to loot it, but to look at it. That, more than any quadrillion-dollar headline, might be the actual treasure this whole tour was pointing toward all along.